Welcome Algebra. This is section 1.3, write expressions. If you look at our learning target, I can translate verbal phrases into expressions. I can evaluate expressions in real life situations. Yeah, that second learning target usually means there's going to be a story problem somewhere. Okay, so hang on, you can do this. All right, we're going to start with our warm-up. Evaluate the expression when x is equal to 3. So that means we're going to substitute 3 in for every variable x. Well, in this first one, I'm going to substitute 3 in for x. You could distribute and then combine like terms, or I recommend order of operations. Let's do what's inside parentheses first. So 3 plus 2 is 5. So I have 3 times 5, we get 15. Now, again, more practice with order of operations. We're going to plug in 3, but now you have to determine what am I going to do first. You don't want to add first, you want to divide first. So we're going to take care of this part. 4 divided by 2 is 2. So 3 plus 2 is 5. Again, 4 plus, I'm substituting 3 in for x. Quantity squared. 4 plus 3 is 7. And I want to square that. You get 49. All right, now writing expressions, this is where we have a lot of verbal phrases. And some of them can get really tricky, especially when you get to subtraction and division. So some key words for addition would be sum, plus, total, more than, increased by. And if you have the phrase that says the sum of 2 and a number, I wrote 2 first, but we know that we can write x plus 2 or 2 plus x, that's fine. But subtraction's you have to be very, very careful. When it says the difference of a number n and 6, you're going to say n minus 6. A number y minus 5, etc. But if you say a number less than 5, that's where you got to be careful. When you have a number less than 5, that would be 5 minus n. So this is a number less than 5. So it's smaller than 5. You take it away from 5. Hopefully you can see that over on the side. Multiplication, keywords would be times, product, multiplied, of. You'll see this a lot. Of means multiply. And another keyword that you don't see on here would be equal. Or the keyword is. Is means equal. Quotient divided by, divided into, that's our division. So let's look at example 1. Slide that up just a bit. Look at this. 7 less than the quantity 3 times the number x. So this is a quantity. That's usually like in parentheses. 3 times the number x. And I want to do 7 less than. We actually don't need this in parentheses because we'll know to multiply them anyway, so it's up to you. The quotient of 4 and, so now I'm going to divide, because quotient means divide. The sum of, okay, so I'm doing the quotient of this whole part. So the sum of 8 and a number. So 8 plus n. So far so good? These can be tricky. Take it slow. Look at all the examples in this video and look at the examples that are in your book, of course the online book. The difference of the square of a number, so that would look like x squared. Remember, that's a key word for square, also to the power of 2. And half a number y. So 1/2 y. But we want the difference of, so I'm going to put a minus sign. All right, so now let's kind of put this into practice. Sometimes you won't really need to use a lot of this information because it'll just come natural. But some people have to really think about this, so help each other out, please. The length of a licorice rope, a super rope, is 34 inches. You broke off 3 pieces of the same length. Write an expression for the length in inches of the remaining piece. Okay, well, basically, the length that we have, it doesn't tell you to solve it. You're going to take the whole length, this 34, and you're going to cut it into 3 pieces, or divide it into 3. There you go. That's it. So, all right. I know, uneventful. Move on to the next page, and notice these are all story-type problems. You can do this. Don't panic. We'll do them in class together anyways, remember? All right. So use a verbal model to write an expression. A basketball player averages 17 points a game. If she played 12 games, how many points did she score in total? Write the verbal model and solve. So this one we also have to solve. So a verbal model, you can say she plays 17 games. Okay, that's it. Well, how many points does she have? You take 17 times, how many games? 17 points per game. 17 times 12. Oh, big number. Not really sure what that is. 17 times 12. 204. It's actually a lot of points. Okay, another basketball player averages 5 shots per game. I already see an error. Let's cross that out and put 7 shots per game. 2 3-pointers and 5 free throws. 5 free throw shots per game. Sorry. Write a verbal model for finding the average. It doesn't tell you to solve, but if you want to, you can. All right, so 2 3-point shots. So I'm going to write 2, we'll use T for 3-point, plus 5 free throws. Maybe use 5 F for free throw. And remember, any variable you want is okay to use. Notice I did not ask you to solve this one, but if you could, it would be each 3-point shot is each 3-point shot is worth 3 points, so you'd multiply that, and each free throw is worth 1 point, so you'd multiply that and then combine. All right, example 4. This is actually true. I looked it up. 2.5 feet of snow fell in Kenosha on February 21st, 1898. That's a lot. Find the unit rate of snowfall in inches per hour. Well, first of all, this is in feet, so we got a little bit of problem, and this is in inches. And I know that 1 foot is equal to 12 inches. So what about 2.5 feet? Well, a half a foot is 6 inches. 2 feet would be 24 inches. So 24 plus 6, that's equal to 30. All right, so they had 30 inches fall on that day. We want to find out how many in an hour. So 30 inches in 1 day is the same as 30 inches in 24 hours. And then if you divide that, I could continue, use fractions. 6 will go into each one of those. We have 5 over 4 inches per hour. And for those of you who hate mixed number or improper fractions, that's 1.25 inches of snow per 1 hour. That's crazy. Be a lot of sledding going on. Probably not snowmobiling if you look at the date. Example 5, last one. In a sprint triathlon, you swim for this much, you bike for this much, and then you ran 25 minutes. Notice this is a time, not a distance, at this rate. Per minute. Where's your total distance? Well, we can add these two up, but I can't add that up because that's a time. But if I take this 25 and multiply by the rate, 25 minutes, and went at the rate of 0.124 miles per minute, we will get a total distance because distance is equal to the rate multiplied by time. I don't know if you recall that. So if you multiply 25, let's clear this, 25, I'm using a calculator, times 0.124, you get 3.1. So that's a total distance of 3.1 miles. So now add them all up. I have 0.5, 12.4, and 3.1. 5 plus 4 is 9, plus 1 is 10. Carry the 1. 3, 4, 5, 6. 16 miles, total distance. You could handle that, right? All right, so here's the homework assignment. We will be hitting this, hopefully, in class. Have a nice evening. Bye.